Everyone, in this video we're going to go through the solutions to the recursion and financial modelling test number 3. So I think we've got 5 multiple choice questions and then a couple of extended response. So let's get started. Use the following information to answer questions 1 and 2. Alright, so we read this during reading time and then we're going to read the question again obviously when we can write and highlight the important part. So it is a loan of $45,000 and we're being charged interest at a rate of $48,000 per annum compounding monthly. It is repaid with regular monthly payments of $2,920 and we want to calculate to the nearest cent the value of the loan after 5 months. Alright, so on our calculator, we just can put everything straight into financial. So obviously you could create a rule and do this using a rule. I probably wouldn't do recurrence relation because, you know, that's a bit time consuming, but financial solver, you could just plug everything in. So in an exam, you really need to save time. I wouldn't be writing down all these prompts. I would have it already written in my bound book and then you can fill it in. All right, so as we read the question, we can fill in our financial solver. Instead of going through N and locating, do it as we read it. So we've got a loan of $45,000. All right, so that's our principal value. And it's positive because it's money coming to us. It's charged at an interest rate of 4.8%. So 4.8 is there per annum compounding monthly. Now remember the last two numbers are going to be the same, so 12 and 12. All right, it is repaid with regular monthly payments of $2,920. So because that money is going back to the bank, we need to put a negative in front. So 2920. And correct to the nearest cent, what is the value of the loan after 5 months? So N is going to be 5, and then we do future value, which we can see there, and we just find our solution. So we can do option C. Now, you should be able to also eliminate some of these questions. We only have the loan for 5 months, and it's $45,000, and we're not really making huge repayments, so obviously can't be A, all right? And that's the amount of the repayment anyway. It can't be the same, and it can't be, well, it could be the same if it was an interest-only loan. So it could possibly be $45,000, but it can't be more, all right? So we pretty much can eliminate quite a few answers if we thought logically about the question. All right, question 2. Following 15 regular payments of the $2,920, a final payment is made to fully repay the loan. The final payment on the loan to the nearest cent. So we want a final payment. So this is where some students find it difficult, but just remember with your, now sorry for all my things, do I have it open? I don't think I've got my formula sheet on here. All right, so go away. All these things popping up. So I've just opened our formula sheet. Now, if you're with me in 2025, this wasn't on your formula sheet, but I did ask you to write it down in class. So if you haven't already written it down, you should have it here. So we're referring to final payments. It's either going to be a reducing balance loan or an annuity. All right, so we got to take note of what is written here once we've put it in financial solver. All right, so let's put everything into our financial solver. I'm going to clear it. Probably didn't need to clear it. All right, so we've made 15 regular payments of $2,920. So that means our next payment is going to be, and final payment is going to be 16. All right, so we've made regular payments of that and then a final payment. So that's going to be payment number 16. It's going to be fully repaid. So I've, oops, actually, can't be 0. So let's come back to that. Payments are the same. So negative 2920. Our interest rate is the same, so I probably shouldn't have deleted it because there's not much going to change. 45,000 is our loan. Oops, and 12 and 12. Now the reason I couldn't make future value 0 is because there's either going, because your final payment the way that because you're taking a percentage each year, it can never be exact. So if I do my future value, we can see we've got $180.07. All right, so we've got to say, well, that amount is extra. So is it extra that I owe to the bank, or does the bank owe it to me? So if we have a look at our formula sheet, so if your future value is negative, then you add that to your final payment. So it means that it's still money that is owed to the bank. But if it's positive, then we subtract it from the final payment. So we've got $2,920 and we're going to subtract $180. So if we just have a look at our options, just so I don't have to write it on the calculator. All right, so it's not going to be D or E, so we need to, I'm going to have to actually subtract it. All right, so I'm going to highlight this because it's the longer number. Go back to my main 2920, and then we're going to paste it in with the minus sign in between. All right, so our final payment is $2,739. So you can see it's either going to be B or C, just depending on your rounding. So it's going to be 93 cents. So we do have to round up to 93 cents. Now with this question here, let's say you didn't know how to answer it, you could probably tell just by looking at the answers that it's probably going to be B or C. All right, we know it's not going to be the same payment, can't be more. So if you had the option between the three, it's just a matter of thinking, well, all right, these two look the same, I'm going to choose B or C. So doing it properly, and I don't think this is a hard question. What makes it hard is you're probably going to put that 15 in here, which will change our future value, and we get this number, all right, which is option A, but you still have to pay interest. So even though there's $10 difference, you've still got to pay that because you've got interest on there. So our answer to that one was C. All right, moving along. Our occurrence relation that generates the sequence is, all right, so we've got the starting values, so they all have 2, 0 equals 2. So our numbers are going up. So 2 to 7 is adding 5, 7 to 22 is not adding 5. So what we can do is eliminate any adding 5. All right, and is there anything else? Are we multiplying by 3.5? So 2 times 3.5 is 7. 7 times 3.5 is not 22. All right, you can test that on your calculator. All right, let's have a look at option B. So this 2tn plus 1. So what we can do is just take this first value. 2 times 2 is 4, plus 1 is 5, so it's not going to be B. Option C, 2 times 3 plus 1 is 7. 7 times 3 plus 1 is 22. 22 times 3 is 67. So it looks like option C is our answer. Let's just test that it's not option E. 2 times 4 is 8 minus 1 does give you 7. 7 times 4 is 28 minus 1 is not 22. Okay, so only one is C for that one. So just substituting in this first value, checking that you get the 7. So we did see we did get that for a few of them, but then substituting in the 7 to see that you get the 22. All right, question 4. Janet deposited, I might highlight as we go, 1,200 in an investment every month for 20 years to save for her retirement. Throughout the 20-year period, the investment fund paid that percentage per annum, compounding monthly. When she retired, Janet purchased an annuity that pays 4.5% compounding monthly, from which she receives a monthly payment for 20 more years. The monthly payment that Janet receives, correct to the nearest cent, is. Okay, so we've got two things going on here. So let's deal with this first part. So she's put in to the bank 1,200. All right, and every month, into an investment fund every month. Okay, so she did this every month. So she started with 0, and then every month she's added in 1,200 every month for 20 years. All right, so just taking out the maths. She gets an interest rate of 5.35% per annum, compounding monthly. So let's have a look at what that is equal to after the 20-year period. All right, so we'll clear what we've got there. So 20 times 12 is how many months? Interest rate is 5.35. Your principal value, okay, so it's an investment, and so she's going to start off with every month. Okay, so she starts off with 0, and she's going to put in 1,200 every month. So it's going to be negative because it goes in. The future value is what we're calculating, and then it's 12 and 12. All right, so we get 5. Here I was thinking that I've done something wrong, and I didn't, because I didn't see the answer there, because I've still got to go. All right, so that's our value of the investment. So 5136. So 513677.49. Just make sure I've got all those digits. Okay, so she purchased an annuity. We've got to round it to 2 decimal places because that amount is now being used in an annuity. All right, so the second part, and I might do that in a different color. Let's do that in blue. All right, so for the next one, her principal value is the 513,677.49. She purchased an annuity that pays 4.5%. So she's not paying anything, she's receiving money. All right, so last time she was putting 1,200 into the account. This time she's receiving a payment, and that's what we've got to work out. All right, every month. And the interest rate is 4.5%. So obviously she's receiving it for 20 years. So again, N is going to be 20 times 12, and your future value is going to be 0 because we want to exhaust that annuity. Okay, so let's just clear everything there. All right, so your N is going to be 12 times 20. Your interest rate is 4.5%. Principal value is the value from before, but because it's an investment, make sure it comes up as negative. And I probably should have just copied and pasted that, to be honest. Payment is what we've got to work out. Future value is 0, and then we've got 12 and 12 because it's compounding monthly. All right, so there's your payment. So 3,249.78. So option D. All right, so 2 steps there, doing the financial solver twice, just getting this value of the investment, all right, and then doing it again. All right, so the conditions have changed. All right, a recurrence relation that generates the sequence is... All right, so what do we... Okay. So for this one, we don't have an initial value, but that doesn't mean that we have to start at 2. That's an interesting question. All right, so what's happening with the 3 to 5? We're adding on 2, and then we're adding on 4, and we're adding on 8. So we're not adding on 2 each time. We're not subtracting 2 each time. All right, are we multiplying by 2? No, we're not, so we can get rid of that one. All right, so let's check C and D. So if we've got, so we can ignore this initial value because this is just a sequence of values. It doesn't actually, like it would be great if it had the starting value is 2, which is a little bit tricky. All right, so let's just substitute in the 3 for option C. So we're going to have 2 times 3 minus 1 gives us 5, good. let's substitute in the next value. 2 times 5 minus 1 gives us 9. That's good. Let's just check the third one. 2 times 9 minus 1 does give us 17. All right, let's just check option E. So 2 times 3 plus 2. So 2 times 3 is 6 plus 2. Does not give us 5. All right, so our only option there is C. All right, moving along, let's do the extended response. I'm going to flip my laptop over. All right, Julie deposits some money into a savings account that will pay compound interest every month. All right, so she's putting money in like an investment. The balance of Julie's account in dollars after VN months can be modeled by the recurrence relation. All right, so just making sure we use V wherever we have to do any working out. All right, so we've got V0 equals 12,000, and then this is your interest rate, well, calculated using your interest rate. So it's your common ratio. How many dollars does Julie initially invest? So we can see it's a question 1. This is very first question of recursion. So it's usually an easy one. All right, so how much does she invest? $12,000. Easy. Recursion can be used to calculate the balance of the account after 1 month. All right, so that's going to be V1. Write down a calculation to show that the balance in the account after 1 month, V1, is that amount. Okay, so we're just going to do V1 is equal to 1.0062 times 12,000. And you could do that on the calculator, but you should have confidence that that is correct. All right, and just making sure you've got that 0.40. All right, we're not a fancy cafe. After how many months will the balance of Julie's account first exceed 12,300? So on your calculator, you can put the values into Financial Solver. The thing is, we haven't been given the annual interest rate, so we would have to work that out, which is a little bit more work, I think, than actually using the sequence. So we can go to the recursion and just change what we've got in there. All right, so our starting value, let me just flip. All right, so putting in our, okay. All right, computer, the calculator cracked it. So start again. All right, so we've got our initial value is 12,000. And then here we put in our recurrence relation. So it's 1.0062 times Vn. So I'm using A here, so I can just go, not to there, sorry, to here, times An, click, and then we get all our values. So we want it to first exceed 12,300, sorry, which I can see there. So after how many months? 4 months. All right, a rule in the form Vn blah, blah, blah can be used to determine the balance of Julie's account after n months. Complete the rule for Julie's investment after n months by writing the appropriate values in the box. Okay, so this is where it's probably a good idea just to refer to your formula sheet. So if we go up, up. So we're doing a compound interest, geometric growth. We've got our recurrence relation. We can see how our rule relates to that recurrence relation. So we've got the same R value, but you'll notice on our exam, it's just the other way around. So the 1.0062 will go there because we've got the power of n. And then the other part, all right, is V0. So we're going to put the starting value in this box, which was 12,000. All right, so for this question, if you should notice that when you multiply two numbers together, it doesn't matter the order, but because you've got the power of n here, you do have to put that 1.0062 in. All right, what would be the value of n if Julie wanted to determine the value of an investment after 3 years? So when let's refer to the formula sheet again, just to get you used to it. So N is the number of compounding periods after the initial investment or loan. So it's 3 years and it's 12 months. So compounding periods are 12 because it's monthly. So 3 times 12 gives us 36. All right, moving on to question 2. After 3 years, Julie withdraws $14,000 from her account. Is this the same question? Okay. Same exam, but because it's now question 2, you don't have to use any information from the previous question. So it's kind of like a standalone question anyway. So after 3 years, Julie withdraws $14,000 from her account to purchase a car. For tax purposes, she plans to depreciate the value of her car using the reducing balance method. The value of Julie's car in dollars after n years can be modeled by the recurrence relation. For each of the first 3 years of reducing balance depreciation, the value of R is 0.85. What is the annual rate of depreciation? So getting used to using your formula sheet. All right, so this is reducing balance depreciation. And you can see how R is calculated here. So R is equal to 1 minus lowercase r over 100, where R is your annual interest rate. So we're going to have 1 minus lowercase r over 100 is equal to 0.85. Now, you can then just solve on your calculator for lowercase r, and you would get 15%. Now, I also know that's 15% because if you think of 85, if you think of your phone, 0.85 is the same as 85%. So you've got 85% left of your battery. How much have you lost? You've lost 15%. All right, so you could get that 15% either by solving this equation or understanding that it's 15% below 100%. All right, I had to edit this video, so if it looks a bit glitchy, I'll just show you. This is my original answer. I did 5 years, then 3 years. It should have been 3 years, then 5 years. So I'm going to read the question and then just explain, redo this question basically. So you probably haven't even seen me do the solution because I've already deleted it. So we've got for the next 5 years of the reducing balance depreciation, the annual rate of depreciation is 8.6%. What is the value of the car after 8 years? So I did 5 years and then 3. I should have done 3 years and then 5. All right, because it was 3 years up here. All right, so I got this question wrong. So let's just fix everything up. What I have done, oh, come on. It's not letting me erase that. Let's try that. So what I've got here is the recurrence relation, although that value shouldn't be there as well. So we'll rewrite the recurrence relation. The second part is right, but my initial value was wrong. All right, so let's find the value after 3 years. So when I did this question, I initially showed you both using the recurrence relation and financial solver. So I might do that again. It's going to work for me. Let's just flip you over. All right, so you can see I've already got that in there from previously, so I'm going to clear that. All right, so I'm going to put this recurrence relation in. So our R value was given to us in the question, so 0.85, and then it's going to be times AN, and then our initial value is 14,000. All right, so we're doing that after 3 years. So here's our amount here. So 8597.75. 8597 can't remember now. 75. So just make sure you highlight it and then read the number down here. So 0.75. And then we've got to do the same thing for 5 years. So my initial value would be the 8597.75. So I'm going to put that in here. I've got to copied and pasted it. 8597.75, and my value of R is 1 minus 8.6 over 100. So I'll just quickly show you on here. All right, so we've got 8.6, oops, so 1 minus that amount. All right, so that's where the 0.914 has come from. So put that back into our sequence. All right, and just make sure I've done that correctly because I hate to do a third video. All right, so we just press on the table to get our values, and now it's after 5 years, and there's our amount there. So 5484, and we need the cents as well. So 23.23. Now we could also use Financial Solver for this question, so I'm just going to show you how to do it on Financial Solver. All right, oops, didn't need to do that. Okay, so for the first one, it was for 3 years. Our interest rate was 15%. Our principal value, so, oops, because it's depreciation, this must be negative. So just quickly going to our formula sheet. So reducing balance depreciation, your interest rate is negative and your principal value is negative. So just refer to this if you're ever unsure. All right, so negative 1400, no 14,000, no payments, and our future value. So we should get the same amount. You can see we've done that. All right, so then we can copy or cut that amount. And now it's going for 5 years. Our interest rate has changed to 8.6. And this time our car is worth a bit less. Just make sure we put negative in because it's depreciation. We're not adding any payments, and there's our future value, which was the same thing. One other thing I picked up is that in my video when I do this question, I think there was a 1 missing there, but you would have seen it on the calculator. But just make sure you do that. All right, bye guys. Moving along. Question 3. The repayment schedule below shows 5 deposits into an annuity in deposit phase. All right, so that means we're actually putting money into our annuity. We're not taking out any money. The annuity earns interest at the annual percentage rate of 6.2% compounding monthly. Monthly deposits of 740 are made. All right, write down the value of A, B, C, and D from the table. All right, so where are we? So we've got A here. All right, we can see what A is going to be. We've got B is going to be the interest, and then balance of your annuity is here, and your principal, oops, C and then D. All right, so quite a few things to find. This question is worth 3 marks. So we've got to think, well, how are we going to get those 3 marks? So you'd have to get all 4 answers to get 3 marks. If you got maybe 3 correct, you'd get 2 marks, and 2 correct for 1 mark. I would say that withdrawal amount, that A value is probably the easiest one to get because it's going to be the same each time. For your interest paid, and I'll show you a formula in a sec, this value here is just a percentage of this value here. So it's told us that we've got 6.2% compounding monthly. So it's not 6.2% of this highlighted value, the 129,652. It's 6.24 divided by 12 of that. So I'll just show you the formula. So I've created, oops, that's not what I wanted. This one here. All right, so just for amortization tables, we're looking at the annuity. So we're making a principal addition, so an annuity investment. We've got our payment numbers, payment we've already done, and the interest. So we're going to use this formula here. So the R over 100 times P times the previous balance. So just below R is your annual interest rate, and have I defined P? No, I haven't defined P. P is your number of compounding periods. I'm going to put that in. P is the number of compounding periods per year. So we're going to use this formula here, R over 100 times P times the previous balance to work out B. All right, so our annual interest rate is 6.24%. 4 over 100 times the number of compounding periods times the previous balance. All right, let me just plug that into the calculator. Whoops, what's going on, guys? There we go. 6.24 over 100 times 12 times 129,652.22. All right, and that's going to be our interest, so 67419. All right, so if you got those two, then you've got 1 mark. All right, let's find C. So this time we're doing our principal increase, so we can refer to our table again. All right, so principal addition means the same as increase. So we do the payment plus the interest. So our payment was 740 plus that interest. So let's put that into our calculator. So 740 plus 696.37. So we get this value. And we kind of want it similar to the previous one. So 143637. And it won't be the same because your interest rate is going to be the same, different. All right, and then D, so balance of your annuity. Okay, so going back to here, the balance of your annuity is your previous balance plus your principal addition. So our previous value for D is this one here, and we're going to add on this. So let me just highlight them in a different color. So we're going to add this number and this number. So the previous balance plus your principal increase. All right, so 131,066.41 plus 1421.55. All right, 132,487. And I feel like I may have written that wrong. 487.96. Put a dollar sign on. All right. Last question, I think. Julie has retired from work and has received superannuation payment of that. Let's view the screen again. She has 2 options for investing her money. So option 1, Julie could invest this amount in a perpetuity. She would then receive that amount each fortnight for the rest of her life. What is the annual percentage rate is interest earned by this perpetuity? A bit of a tongue twister there. All right, so we can go to Financial Solver and we're going to clear. All right, so she would receive, actually we don't need to do, we could do that on Financial Solver. All right, so when you're doing a perpetuity, the number of periods actually doesn't matter as long as it's not 0. So you can just put 1 there. The reason for that is because your principal value and your future value are actually the same, but your principal value, because it is money that's going into the bank or wherever, it's got to be negative, and then it's going to be positive for the future value. All right, compounding. I did say fortnightly. Where did I say fortnightly? She was retired and received superannuation. She has options. She could invest that in a perpetuity, receive each fortnight. Okay, I even highlighted it. It's not 14. That's how many days in a fortnight. There's 26 fortnights in a year. All right, and she's receiving, and this is positive because it's money coming to her. So there's your interest rate, 4.86%. Was it 86 or 68? 68. All right, option 2. Julie could invest 492,800 in an annuity instead of a perpetuity. The annuity earns interest at the rate of that, compounding monthly. The balance of Julie's annuity at the end of the first year is this. What monthly payment would Julie receive? Okay, so let's, we'll keep in what we've got there. She's doing it for 1 year, so it's going to be 1 times 12, so 12 months because it's compounding monthly. 4.32 is your interest rate. Principal value is the same. Payment is what we're going to work out, and it's no longer fortnightly, it's monthly. Now, her future value after 1 year is 480, and this is positive, 242.25. So just make sure I entered all those values incorrectly. All right, so she's going to earn $2,800. All right, how much interest would Julie's annuity earn in the second year of investment? Round your answer to the nearest cent. All right, so we've got how much interest is she earning. So it's not the interest rate, it's the amount of interest she receives. And we want it in the second year of the investment. So after year, so we're going from year 1 to year 2. All right, so after year 1 or 1 year, she's got this amount. Whoops, 242.25. And we've got to work out how much it is in year 2. So we can just change this to 24. Get rid of all this because it's just going to be 2,800. So the future value is this amount. So 467,131.14. All right, and we're going to subtract that to find the difference. So I'm going to just make that a 4 to round it, copy. All right, so we're going to copy that so I don't have to write it again. I'll type it again. 480,242.25 minus, and then we can just paste that number in. All right, so she's got 131111. Now remember, over this period of time, she's also been receiving these monthly payments. So the difference in this value is also because of the payment she receives. So we've got to work out how much she receives in payments as well. So 2,800 times 12. So 2,800 times 12. So the difference between these two values is how much interest she receives. So we'll just go back to the calculator. So we're going to subtract, and I can just copy this down. So highlight and drag it down. So she's received $20,488.89 in interest. All right, sorry, I just had a bit of a glitch. So there's your answer. So $20,488.89. And I think that was the last question. So probably ending on quite a difficult question. But you know, you've got to have those harder ones in to separate the top students. So 2 marks. If you got 1 mark, probably just getting for this value here for year 2. But if you couldn't go on from there, at least you got 1 out of the 2 marks. All right, guys, bye.